outside the shop.
Room 162 is always a little bit warm. I'll just warn you of that right now, just so you can prepare for it. Okay, so looking at these problems here. Number one, 73 1/3%, we're asked to convert that into fractional form. Not a fractional percent, but fractional form. So, to turn that into that basically a ratio, 73 1/3% is 73 1/3 out of 100. And probably the easiest way to convert that is to just divide it out. So 73 1/3 divided by 100. Now we'll make this 100 over 1, so we're dividing by a fraction. And then we have to turn the 73 1/3 into an improper fraction. 73 times 3 is 219, plus 1 is 220 thirds. And instead of dividing by 100 over 1, we're going to multiply by the reciprocal. So we're going to multiply by 1 over 100. Now, both 220 and 100 can be divided by 20. 220 divided by 20 is 11. 100 divided by 20 is 5. So 11 times 1 is 11. 3 times 5 is 15. So 73 1/3% is the same as 11 out of 15. Any questions on that? 418.75%. Well, again, that's 418.75 out of 100. Now, there's two things we have to do here. First, this is an improper fraction. We'll have to take care of that. But we also want to get rid of the decimals within our fractions. Now, this since it is over 100, it's going to be simplest to turn it into a mixed number. So I'm going to do 100 goes into 418 4 times with 18.75 left over. So we now have that 18.75 over 100 that we have to deal with. Now, some of you might recognize that 0.75 is 3/4, and we could multiply both the top and bottom by 4 to get rid of the decimal. If you recognize that, that's great. That'll save you some work. But if you don't, remember, we can always just say, hey, there's 2 decimal places. To get rid of them, we multiply by 100. So 18.75 times 100 is 1,875. 100 times 100 is 10,000. Both 1875 and 10,000 can be divided by 25. 1875 divided by 25 is 75. 10,000 divided by 25 is 400. Well, both 75 and 400 can still be divided by 25. $75 divided by 25 is 3, and 400 divided by 25 is 16. Can't forget the whole number of the 4 in front of it. So 418.75% is 4 3/16. Any questions there? Okay, so for 3 and 4, we're asked to convert those into percents. For 3, 7/8 or 7 out of 8. A percent is out of 100, so how much is that out of 100? 7 times 100 is 700. Divided by 8 is 87.5 out of 100, or 87.5%. .83 as a ratio, or sorry, as a rate, that's 0.83 out of 1. We want it to be out of 100, which means we multiply by 100, remove the decimal point 2 spots to make that 8.3 out of 100, or 8.3%. Any questions there? Okay. So, that's our converting back and forth between the different forms of the percents. today we want to move on to calculating. Last week we left off, we talked about benchmarks and how we could use those benchmarks, mostly 10% and 1%, to estimate an answer so that we could at least double check to see if what we get is reasonable, and even in some cases to calculate some simple percents by just doing combinations of 10 and 1%. So today we want to take that next step and look at calculating it exactly. So we're going to first talk about the proportion method. Now I'm going to note here that I'm leaving the right side of my page blank on purpose, because we're going to come back and we're going to redo all of the problems that we do here, or at least most of them, using another method called the rate method. So the proportion method of percents uses what we were doing at the end there with last week when we were converting fractions into percents. If we had 3 out of 4, a percent is out of 100. It looks something like that. And we cross-multiplied and divided to find the missing number. And so for our proportion method, get something like 35% of, let's see here. Let's go forward. So we're going to start off with the percent. 35%, of course, means 35 out of 100. Now, before we do anything else, let's talk about what those two numbers mean in that ratio. Remember, 35% is a ratio, 35 out of 100. Well, the 100 represents the whole thing, or often what is referred to as the base amount. It's the base amount because it is the amount that all of our other calculations are based off of. So you think of it as being the whole thing or the beginning amount. It's what we start with. The top number then, in this case the 35, is what's referred to as a portion of interest. It's a piece of that base amount that we are focusing in on, that we're interested in. Now, I'm being careful using the word piece because it's not always smaller than the base amount. Sometimes that portion is actually larger than the base amount if we get a percent larger than 100. And we'll see at least one example of that before we're done today. So now we have to finish off our proportion. And on the other side, we need to make sure these numbers match up with the numbers within our percent. There are always two other numbers in the problem. One, in this case, is the number we're looking for. We're asked to find 35%. That implies that the number we're asked to find matches up with that 35. Of 40, we can read that as out of 40, implies the 40 goes on bottom. So it's our missing number out of 40. And now, of course, our calculation is to cross multiply and divide. Remember, we multiply the two numbers that are diagonal to each other. So 35 and 40, which is 1,400. And then the number that is diagonal with the missing number, we divide by. So we divide by 100 to give us 14. So 14 is 35% of 40. We might have something like blank is 125% of 48. Once again, we start with the percent. 125% is 125 out of 100. Now, one thing you'll notice here right off is 125% is bigger than 100%. So here's a case where that portion of interest is going to be larger than the base amount. Blank is 125%. That implies that missing number matches up with the 125. Of 48, again, we read that as out of 48, implies the 48 goes on bottom. Now, once again, we've put all the numbers in the proportion except for one missing number. So the process is to cross, multiply, and divide. The two numbers that are diagonal are the 125 and 48. 125 times 48 is 6,000. The number that's diagonal to our missing number is the 100, so we divide by 100. That is 60. So 60 is 125% of 48. Let's look at one that's worded a little bit differently. %, of 45 is blank. So looking at this one here, we have the percent again, 80%. So we start out 80 over 100. Of 45, once again, we would read that as out of 45, implies that the 45 goes on bottom. 80% is blank, implies that our missing number, the blank, goes with the 80. Now again, it's simply cross, multiply, and divide. 80 times 45 is that 3,600? And we divide by the 100, giving us 36. 80% of 45 is 36. Well, these first three problems have all been worded slightly differently, but they've had the same missing component. Let's do something just a touch different here. Let's do 42 is 60% of blank. But once again, we have the percent, 60%. So we start out with 60 over 100. On the other side, well, we have 42 is 60%. That implies the 42 goes with the 60. Of blank, once again, we read that as out of blank, implies that missing number is on bottom. Now, the missing piece is in a different spot here, but our process is still exactly the same. We're going to cross multiply. So we find the two numbers that are diagonal with each other. That's the 100 and the 42. We multiply those, you get 4,200. Then the number that's diagonal with our missing number is the 60. So we're going to divide by 60. Get 70. 42 is 60% of 70. I might have one that says 15% of blank is 5. Once again, I have my percent, 15%. 15 out of 100. Remember, a percent is always out of 100. On the other side, this is of blank. So if I read that as out of blank, that implies my missing number is on bottom. 15% is 45, implies the 45 goes with the 15. Once again, it's in a proportion. Find the two numbers that are diagonal and we multiply them. That'll be the 100 and the 45. 100 times 45 is 4,500. Then the number that's diagonal with our missing number is what we divide by. We divide by 15. 4,500 divided by 15 is 300. 15% of 300 is 30, or is 45. We might have something like this. 27 is blank percent of 30. Well, all the other problems I've told you we have to start with a percent. Here, however, we do not have the percent. It doesn't change anything. We're still going to start with it. Blank percent is just going to be blank over 100. We now know that's the number we're going to be looking for. So we're going to know both of the numbers on the other side. 27 is blank percent, implies that 27 goes with the missing percent. Of 30 can be read as out of 30, implies that 30 goes on bottom. Now we are ready to cross, multiply, and divide. Now, once again, the missing number is in a different spot, but the process is still the same. We find the two numbers that are diagonal. 127, so we multiply those. 100 times 27 is 2,700. Then the number that's diagonal to the missing number is what we divide by. We divide by 30. 2,700 divided by 30 is 90. So that's 90 out of 100, or 90%. 27 is 90% of 30. We might have blank percent of 60 is 24. Once again, we're missing the percent, so we'll start out with blank out of 100. Of 60 can be read as out of 60, implies the 60 goes on bottom. Blank percent is 24, implies the 24 goes with our missing percent. Once again, we cross multiply the two numbers that are diagonal. 100 times 24 is 2,400. And we divide by the 60, giving us 40. 40 out of 100, or 40% of 60, is 24. Any questions there? I'm a big supporter, a big fan of the proportion method, because the only challenge is getting the numbers in the proportion in the correct spot. Once they're in there, the calculation is always the same. Cross, multiply, and divide. Let's take a look at the rate method. The rate method, of course, involves always the base step. We're going to convert the percent to a rate. And then we'll go from there. So for the first one here, our percent is 35. That's 35%. As a rate, that's 0.35. There's the decimal 0.35. Now, if we have the base, the calculation is the portion equals base times rate. So here we have our base was 40 times our rate of 0.35. 40 times 0.35 is 14. Our answer was. Second one here, our percent was 125%. As a rate, that's 1.25. We are given a base of 48. 48 times 1.25 is 60. Now, so far in these first couple, it seems actually a lot easier to use this rate method. And I wouldn't argue with you on that, on those problems. Even on this next problem, it'll be pretty easy. We have a percent of 80%, which is a rate of 0.8. We have a base of 45, so 45 times 0.8 is 36. So on those first few problems, this rate method was very easy, very simple, and quick. Now on this next problem, we have 60%. As a rate, that's 0.6. However, we do not have the rate. We are given the portion. If we have the portion, the base is equal to the portion divided by the rate. So We have our portion of 42 divided by that rate of 0.6 gives us 70. The next one, 15% is our percent. As the rate, that's 0.15. We are given a portion of 45. 45 divided by 0.15 is 300. Now that wasn't horrible, but there is that difference when we're using this rate method. We have to decide. First of all, we have to be able to identify, do we have the base or do we have the portion? And then we have to decide, do we multiply or do we divide? But there's even a third type of problem, like these last two, where we are not given the percent. So if we don't have the percent, then we have to do the portion divided by the base. That gives us the rate. So here we have the portion of 27 over the base of 30. That divides to be 0.9, which is 90%. The next one down here, we have a portion of 24 over a base of 60. That divides to give us 0.4, 40%. Now, many of you, especially if you're closer to my age group, this is the way you were probably taught how to do percents when you were young. It is quicker. And if you're good at memorizing and can remember when to use which method, yes, it is quicker and probably faster or easier to do. But I see a lot more mistakes made with this because people pick the wrong method. Whereas with the ratio or the proportion method, all you have to do is get the numbers in the proportion and match them up with the piece of the percent that they match up with. Now, with that said, there is a use for the rate method. That rate method is most useful when we know the base. If you know the base and the percent, you can find the proportion very quickly with that rate method. That happens a lot. There's applications like interest, commissions, even discounts, where we know the base and we have to find that portion. So using that rate method of the percent is a lot quicker, saves us a lot of time and effort. I prefer the proportion method because it's always the same calculation. There is no deciding, do we multiply, do we divide, do we have to move the decimal first or last? It's always get the numbers in there, cross, multiply, and divide. The second reason I like that proportion method is when we get into problem solving, a lot of times the problems, as long as we keep track of what each number stands for, help us set up that proportion. For example, FMD Corporation estimates weekly profits as 8% of gross weekly sales. Find the gross sales for a week when profits are estimated at $29,760. Now, we have a percent here, the 8%. So we'll start off with that. We're going to be dealing with 8% or 8 out of 100. In this in a percent problem, every item is described by two different numbers. One of those numbers is a percent. So here we have actually two items in the problem. We have weekly profits, technically estimates of weekly profits, and gross sales, or gross weekly sales. Now, if you think about it, it wouldn't make sense for sales to be a portion of the profit, because sales would be this big thing. We got somebody shuffling some papers, some echoing on the microphone. Right, that's a lot better. If you're shuffling around, if you're underneath the microphone, it causes a lot of feedback on us. Thanks. So if you are, you have the gross sales, that includes your cost of the item, labor, overhead like electricity and stuff like that, and the profit. So it makes sense that profit is a piece or a portion of the gross sales. The 82 or the 8% is the profit. That represents the profit. The 100% is the base amount of the whole thing. That's the gross sales. So now on the other side of things, the $29,760, the estimate of the profits. Profits, that has to go on top. Because the 8% represents the profits, it's on top. So the other number that represents the profits also has to go on the top of our proportion. And now we solve by cross multiplying and dividing. So 100 times 29,760. And then divided by 8 gives us $372,000. The gross sales for the week were approximately $372,000. Any questions there? Okay, so look at another problem. Let's say Sam receives a 12% trade discount. A trade discount is, like for you guys, many of you are in construction or going into construction or cabinetry. A trade discount is when you own a business or you're a craftsman and you buy a lot of merchandise from a single supplier. Because you are a business yourself, they're not going to charge you as much as they would just the average customer off the street. For a couple of reasons. One is it's a custom to extend that courtesy to other businesses. Second, as a business, you're going to be buying greater volume from that supplier, and if they can keep you loyal, it's going to be less effort for their sales force. They don't have to go out and seek your business. You're going to give them their business because you're getting that discount. So they're getting a large volume of business for very little effort, so they don't need as large of a profit margin. They can make a little less per item because they know they're going to be selling you more items. So we ask, how much does Sam pay for supplies listed at $2,700? So now listed means list price. List price is the price that anybody off the street would pay for those items if they purchase from that supplier. So we have the 12% here. We'll make that 12 over 100. Now the 12 represents that trade discount. The 100% represents the whole thing, or in other words, that list price. On the other side, we have the 2,700. That is the list price. That's going to go on bottom. We cross multiply and divide. 12 times 2,700 divided by 100 gives us 324. But remember, this 324 represents the trade discount. That's not what we're asked here. We're asked how much does Sam pay for those supplies. So what Sam pays is the list price of $2,700 minus, where is it over here, $2,700 minus that discount of $324 to get a amount paid of $2,376. If we look at what happened here, the $2,700, of course, is the list price. From that list price, we subtracted the discount, which was the $324. That gave us the amount paid. Well, as we said, in a percent problem, every item is described by two numbers. One of those numbers is a percent. The other number is, in this case, a dollar amount or some other sort of numerical amount. So these are all dollar amounts over here, the 2,700, the 324, and the 2,376. The other side of this equation, remember, the list price was 100%. The discount was 12%. It's list price minus discount. Well, we can do the same with the percents. 100 minus 12 is 88%. The amount paid is 88% of the initial amount. So we could have taken 88% of that list price of $2,700. And when we cross multiply and divided, we would have had $2,376. So that could have saved us a little bit of work. Now, in a problem like this one, you're going to get to that same answer no matter what. You don't need to subtract the discount percent from 100. But there are problems where that's your only option. For example, after a 6% trade discount, Pat pays $2,376. Is that going to work out? Let me try this. Let's do $2,538. Let's change that. For supplies. After a 6% trade discount, Pat pays $2,538 for supplies. What was the list price? Well, many of you would be tempted, probably most of you would be tempted, to jump in and find 6% of this and add it back on. The problem is the 6% is not calculated off that. That is not the base. The base is the list price, and we don't know what the list price is. But if we look at what we did here before, we have the list price, subtract that discount, it gives us the amount that is paid. So we have percents on one side, and again, we're working with dollar amounts, so we have dollars on the other. We have that $2,538 is the amount paid. That's the only dollar amount we know. Well, we have the 6% discount. which looks like the only percent we have, but there's 1% we always have. That is the base amount, the 100%. The list price is our base amount. That's where we started with the price. So that is 100%. 100 minus 6 is 94%. So that tells us the amount paid is 94%. So 94% is 94 out of 100. The 94 represents the amount paid. So we put the 2,538 there. The 100 represents the list price, which is what we're looking for. So we cross multiply and divide 100 times 2,538 divided by 94 gives us 2,700. So the list price here was 2,700 again. So these last couple examples stress for us the importance of a couple of different things. One is making sure we know what each percent represents and make sure we're matching up numbers here in that proportion that represent the same thing. The second thing that's important is making sure that once we get our answer, or once we've done a calculation, we know what the result of that calculation represents. And we go back to the original problem and make sure that is the answer to the question being asked. Like this one up here, we found the 324, but we weren't asked what the discount was. We were asked what was the amount paid. So we have to make sure once we've done a calculation, it's really easy to write down the answer to that calculation and move on. We have to make sure that that actually answers the question that was being asked. We do have a little bit more homework here today, a little bit larger homework. Two sections. Both of them for everybody out of the little book. It's Unit 16, the odds. This is on percents. And also for everybody out of the big book. Only one big. The big book. It's page 209, exercise 5-7A, problem 7 through 13, the odds. Page 211 through 212. This is exercise 5-7B, problem 7 through 15, the odds. And finally, page 214 to 215. Exercise 5-8, or 5- this should have been 5-8A up here, not 5-7B. This will be exercise 5-9, 7 through 15, the odd. So there's your homework. You guys can have a few minutes to get started on that. A little bit of a note, there is one more quiz left in Unit 1 that's tomorrow. It's actually on Blackboard already if you would like to get started on it. And then remember, our test 1, our first test of the semester is on Thursday. So there's a quiz tomorrow, there's a test on Thursday. So the way that works is, it'll be on Blackboard. It'll be open from 12:01 a.m. to 11:59 p.m. So you have 24 hours. You have any time during the day on Thursday to access that test and then submit it back into Blackboard. Class on Thursday, I will be here, but there won't be any lecture or presentation, no new material presented. It'll only be if you have questions on the test, come in and ask them, and I'll help you with them. Otherwise, I mean, class on Thursday is completely Also, I do recommend that you go back and look through the grade book in Blackboard. Make sure all of your quizzes have a grade. If they have a score of 0 or 0.1, 0 means I didn't receive them at all. 0.1 generally means I received it, but the file wouldn't open. Make sure you look at that. If your grade in Blackboard is less than 80%, you have some work to do because you guys all have another class to take in the spring. 80% is important for us. If you don't get at least 80%, you cannot take the spring class. So if you are less than 80%, remember you can do corrections on any of the quizzes. Actually, after the test is completed and we grade the test, you can also do corrections on the test. But make sure you are doing those to get those points as we go through. By next week, I won't let you do any corrections on the Unit 1 quizzes anymore. So you need to get these done now. If you have any questions.
How about on test 4? Have you graded those yet?
Quiz 4, that should be posted, yes.
So Todd,
Yes,
so
sir.
our quiz, do we need to submit that to you tonight or is it tomorrow night?
The quiz for percents actually won't even be assigned till tomorrow. So that won't be due till noon on Thursday. But I just wanted to warn you that it's out there. So if you do the homework and you're feeling good about the percents, you can go ahead and do the quiz. Any other questions?